And here we have page 2 of your chapter 10 study guide tutorial video. So number 9 and 10, it says write each equation in standard form. State whether the graph of the equation is a parabola, circle, ellipse, or a hyperbola. So very similar questions to the ones that we did before this. In order for you to figure out which one of the conic sections it's going to create, you need to look at your A value and your C value. For number 9, A, our coefficient of our x squared term, is 4. And notice there is no y squared term, which means there's only one squared term. Or you can think about it as C is equal to 0. And when that happens, that implies that our conic section for this is going to be a parabola. To write it in standard form, parabolas have their squared term on one side and everything else to the right side. So I'm going to do a couple of steps in one. I'm going to take these x terms here, leave them where they are on the left side. I'm also going to factor out a 4. So I'm going to have x squared minus 4x. I'm going to leave room for plus c. And that's going to equal, I'm going to put everything else on the right side. So when negative y goes to the other side, it's going to be y. And then minus 21. And then we're going to go ahead and complete the square. In doing so, we'll take b, which is negative 4 over 2, squared. Negative 4 over 2 is negative 2 squared, which is 4. So I'm going to add 4 here. Now, when I add 4 here, I'm technically multiplying this 4 on the outside as well. So on the right-hand side, I'm actually adding 4 times 4. On the left side, I've got 4 times this trinomial can be rewritten as x minus 2 squared equals y. Negative 21 plus 16 will be negative 5. And the only other thing to do is this 4 on the left side, it needs to be written on the right side, but this y minus 5 binomial needs to stay together. We don't want to distribute anything. So we'll end up with x minus 2 squared, and it's like if we multiplied both sides by 1/4. It would cancel on the left, and then on the right, we would have 1/4 times y minus 5. And that would be our answer in standard form. For number 10, again, we got to figure out which conic section we're even dealing with first. So my x squared term, my coefficient for that A is negative 4. And C is my coefficient for y squared, which is just 1. So this is a scenario where A and C, they're not equal. And most importantly, they have opposite signs. One's positive and one is negative. When they have opposite signs, that implies that the conic section is a hyperbola. So hyperbolas are going to be an x squared or a y squared term, either one, minus the other is equal to 1. So just because my y squared term is first, actually, we want to put our positive term first. So I'm going to leave the y's first. So it'll be y squared minus 6y plus room for a new c minus, here's where things get tricky. I'm going to factor out a minus 4 because my x squared term needs to have a coefficient of 1. So then I'm left with x squared. When you factor out negative 4 from minus 8x, it leaves you with plus 2x. So you have to be careful to factor out that minus sign as well. Plus room for a new c equals 95. So then we're going to complete the square twice. The first one will be negative 6 over 2 squared, which will be negative 3 over 3 squared, which is positive 9. So when I add 9 here, there's nothing being distributed on the outside. So it's literally just like adding 9 on the right side. And then when we complete the square for the x's, b over 2 squared, which will be 2 over 2 squared, which is 1 squared, which is 1. Now, when you add 1 here, technically, we're distributing this negative 4 to that 1. So when I add, I'm technically adding 1 times negative 4, or technically just subtracting 4. So then when I clean all this up, my trinomials can be rewritten as y minus 3 squared minus 4 times x plus 1 squared is equal to 95 plus 9 minus 4 is going to be 100. Now, we have a hyperbola, which hyperbolas must equal 1. So at this point, we need to go ahead and divide everything by whatever's going to make the right-hand side 1, which is 100. So when we divide, there's no coefficient to the y's. So that's just going to stay as y minus 3 squared over 100. Minus, when you divide 4 over 100, that's 1 over 25. So that'll be x plus 1 squared over 25 is equal to 1. And there's our final answer for the hyperbola. Number 11 and 12 say write an equation for the hyperbola that satisfies each set of conditions. So I've got a hyperbola going on, and they tell us some information, and we have to use that information in order to write the equation. So we just did a hyperbola in number 10. So we know that it's one of your terms is square minus the other term, which is also square, and must equal 1. So we need h and k. That's going to give us the center point. And then we need a and b, and those are going to be our denominators once we square them. So the first thing that we have to figure out is which one of our equations are we even dealing with? Are we dealing with a positive x squared term that's going to be first? Or are we dealing with a positive y squared term that's going to be first? So I like to sketch out the information that they tell us and figure out which one that's going to be. So if we just kind of sketch out this hyperbola, let's see, this first one, okay, it's got vertices at 0, 12, so maybe that's up here, and 0, negative 12, perhaps that's down here. And it says it has a conjugate axis of length 8 units. Now, it's not talking about this axis between the two vertices. The conjugate axis is between the other vertices. So that full length would be 8. Okay, so our conjugate axis is not the main axis. Our main axis, if these are the vertices, means that our hyperbola is going to be opening up and downward. If it opens upward and downward like this, that means we have the y squared term first. Okay, so that's how we know our y, just like number 10, the y squared is going to be first and positive minus the x squared term. So now we have to figure out what are all of our things. Now, it tells us the vertices are 0, 12, and 0, negative 12. Well, that's enough for us if you know to use one of your equations that the vertices in a hyperbola that has y squared first is going to be h and then k plus or minus a, then it is evident that h is 0 and that k is going to be 0 as well, because plus and minus a will be that plus and minus 12. Okay, so that tells us that our center point, hk, is going to equal 0, 0. Okay, it's also telling us that on our main axis, so the main axis is the distance between those vertices, that a, well, it's half the distance, I should say, that a should equal 12, because the total length is 24. So a is half of that length. And then it says that the conjugate axis is 8 units long. That's the smaller one, or not the main one, I'll say, which implies that b will equal 4. Okay, so if that's b is equal to 4, and we already know what a is equal to 12, then we simply need to plug that into the hyperbola equation where y squared is first. So there is no h and k movement. There's no left and right. So instead of y minus k, it's just going to be y squared over a squared is always first. 12 squared is 144. Minus x squared over b squared, which is 4 squared, which is 16, equals 1. Okay, number 12, again, still a hyperbola, except I'm given some different pieces of information. This time I'm given the vertices and the foci. So again, I want to just kind of sketch where these vertices are to figure out what kind of hyperbola are we dealing with. Well, the vertices are at negative 10, 1. So maybe over here, negative 10, 1, and positive 4, 1. So if these are the vertices of the hyperbola, then it must go outward like this. When a hyperbola flips to the left and to the right, then we know that the x squared term must be first. Okay, other pieces of information. Vertices in a hyperbola that has the x squared term first like this are given by h plus and minus a, comma, k. Now, K we know is 1 because that's the y value of both of these vertices. So if K is 1, then we have to figure out what H and A are somehow. So here's the deal. We know that -3, oh wait, we already know H. Here's why. If you look at our foci and a hyperbola are given by H plus or minus C, comma, K. So again, we already know K is 1, so H must be -3, and C must be the square root of 70. So if I write that information down, so we know that HK is -3, 1. That's just given from the information that we can deduce from the vertices and the foci. So again, in order to write the equation of the hyperbola, we need to figure out what A and B are, because those are going to be our denominators. Well, if we use this number here for our vertices, so if we know that, I'll leave it as green, okay. So if we know that H plus A is equal to -10, so let me do that. H we know is -3 plus some number A is equal to -10. So I'm looking at where the x values of the vertices are coming from. And that H minus A, so H is -3 minus some value A is equal to 4, then I can solve for A, right? So I can, literally just do a system of equations here if you want, or just kind of deduce your information. So A minus, if I add this system, A minus A is 0. -3 plus -3 is -6, is equal to, oh, -6. Hello, okay, I've got to figure out what this is. I don't really have to solve the system, just use your logic. If I add 3 to both sides, then I end up with A must equal to -7 in order for this to be true. So you don't even have to solve the system because it's just one variable. So -3 minus 7 is -10, and -3 minus -7 changes to plus a positive 7 is equal to 4. So we know A is equal to -7. Okay, in a hyperbola, okay, we know that C is equal to the square root of 70. So if we know that C is equal to the square root of 70, and in a hyperbola, we know that C squared is equal to A squared plus B squared, then we already know A and we know C. So I can substitute those values in to figure out what B is. So then C squared would be square root of 70 squared is equal to A is -7 squared plus B squared. So -70 squared, or sorry, not negative, square root of 70 squared is literally 70 equals -7 squared is 49 plus B squared. So subtract 49 from both sides and you get 21 equals B squared. So B is going to equal plus or minus the square root of 21. So I know what A is, I know what B is, and I know what H and K are. And I know that that x squared term is positive and it must be first. So when I fill in that information, I'm going to get x minus h will be minus -3, which will change to be a +3 squared over a squared, which would be -7 squared, which will be a positive 49, minus y minus k, so it'll be my y minus 1 squared, over b squared. Well, b is the square root of 21, so the square root of 21 squared is literally just 21. And that is equal to 1 for that hyperbola. Okay, number 13, it says find the coordinates of the vertices and the foci and the equations of the asymptotes for the hyperbola that has this equation. So again, the first thing that you can't forget is that I'm not always going to give you the equation in the form that it needs to be in. In order for you to gather all of that information, you need to first be in standard form. In order to be in standard form, your hyperbola must equal 1, which it does not. So in order for that to happen, I need to go ahead and divide everything by 4. So when I do that, my coefficients of these are just 1, so it won't simplify. So we're literally going to have x plus 1 squared over 4 minus y minus 3 squared over 4 is equal to 1. Okay, so there's the equation of my hyperbola. So the first parts, we don't really care where the center is. as a part of the answer, but you definitely need to know that in order to find the vertices and the foci. So I'm going to say, okay, I know that the center is going to be at -1, 3. Okay, so the vertices, let's find those first. One of our formulas, the vertices in a hyperbola that has, notice our x term is squared first, is going to be h plus or minus a, comma, k. So we just need to substitute in this information. H is -1 plus or minus a. Well, if a squared is 4, then that means a must be 2. So -1 plus or minus 2, comma, k is 3. And as I mentioned earlier, just in class as we learn this, I actually want, anytime it's not a radical, I actually want to know what these two answers are. So like if you actually do -1 plus 2, comma, 3, then that's going to be the vertex. -1 plus 2 is 1, comma, 3. And the other option is -1 minus 2, comma, 3. -1 minus 2 is -3, 3. So I actually want you to solve those out and give me those integer answers. So 1, comma, 3, -3, comma, 3. So those are the vertices of this hyperbola. Next is going to be the foci. So the foci are given by the expression h plus or minus c, comma, k. So very similar to what we just did for the vertices, except we're adding and subtracting c from the h value. So we now have to go find c. Well, in a hyperbola, we know that c squared is equal to a squared plus b squared. And we know a squared and b squared from the original equation. So c squared is going to equal 4 plus 4, which means that c squared is going to equal 8, which means that c is going to equal plus or minus the square root of 8, which is plus or minus the square root of 4 times the square root of 2, which is plus or minus 2 square roots of 2. Okay, so c is 2 square roots of 2. So when I substitute that in for the foci is going to be h is -1, plus or minus c we just found is 2 square roots of 2, comma, we know that k is 3. So this is an example where I'm okay with you leaving your foci written as one expression instead of splitting the plus and minus up, since your second number is a radical. Okay, so we found the vertices, there was the foci. The last thing is the equations for the asymptote. An asymptote that has your x squared term first is given in the form y minus k is equal to plus or minus, I'm going to mess this up if it's a over b because I only have the answer written on mine. Let's just go ahead and write down the answer. Y minus h, we know h is -1. No, sorry, it's y minus k. So it's going to be y minus 3 is equal to plus or minus 2 over 2. A and b are both 2, so in this case it doesn't matter. But I will say, if you're watching this question in particular, make sure that you check and have that written on your note card if it's plus or minus a over b or plus or minus b over a. In this case, they're both 2, so it doesn't matter. Times x plus 1, and then we'll just go ahead and simplify. The only thing I want you to simplify is plus or minus 2 over 2 is plus or minus 1, which we don't need to write that coefficient of 1. Otherwise, leave your asymptotes in this equation. Okay, you don't need to multiply everything out to get it in slope-intercept form or anything like that. Okay, the last 3 questions on this second page deal with solving systems. So we are going to incorporate substitution, elimination. We might include some factoring. We might include some use of the quadratic formula. It's just kind of a multitude of different algebraic solutions, or not solutions. Yeah, I guess solution methods would be better. All right, I don't know what happened here, but in the second one, so we had x minus y equals 2. The next one should say x squared minus 100. X squared equals 100 minus y squared. Don't know what happened there. Okay, my recommendation for this one, we don't have any variables that have common exponents. So when that happens, elimination is probably the way to go. So if I'm going to eliminate, I'm going to go ahead and solve my top equation, or sorry, if I'm going to substitute, I'm going to go ahead and solve my top equation for x, which is going to be 2 plus y. And then I'm going to substitute this value for x into the second equation. So instead of x squared, I'm going to have 2 plus y squared is equal to 100 minus y squared. And then my goal is to solve for y. So 2 plus y squared is the same thing as 2 plus y times 2 plus y equals 100 minus y squared. And I know many of you can FOIL that out in your head, but especially for tutorial's sake, I don't want you to miss the inner and outer terms. When we distribute, 2 times 2 is 4. Then you do your inner into outer, which is going to be 2y plus 2y, which is 4y. And then y times y is y squared. That's equal to 100 minus y squared. And then from here you can do a few different things. I'm trying to isolate y. So I will go ahead and add y squared to both sides. And then I get 4 plus 4y plus 2y squared is equal to 100. And I'll go ahead and subtract 100 from both sides. And then while I'm at it, I'm going to reorder this since I'm noticing a quadratic occurring. I'm going to go ahead and reorder this. I'm going to say, okay, 2y squared plus 4y, and then 4 minus 100 is negative 96 is equal to 0. So when you get to this point, it's kind of up to you as to what method you want to do to solve this. Some of you may go directly to the quadratic formula. I always try to factor first if possible. First method of factoring you should always try is GCF, greatest common factor. I noticed that all three of these terms have a 2 in common. So if I factor out a 2, I'm left with y squared plus 2y minus 48 is equal to 0. Now I can figure out, okay, what two numbers multiply to be negative 48 and add to be positive 2. And then I can fill in these binomials. Well, hopefully you come up with the numbers negative 6 and positive 8. And then when we solve this, what values of y make this true? We get y is equal to 6 and y is equal to negative 8. So the key is when you get that y's or these values, you're going to substitute them back into one of your original equations. It doesn't matter which one to figure out what the x should be. So I'm going to substitute it back into this very first equation that I kind of manipulated that says, okay, x is equal to 2 plus y, which in this case y is 6, which gives me the answer 2 plus 6 would give me an x value of 8 comma 6. And then x is equal to 2 plus y, in this case is negative 8. So 2 minus 8 is negative 6, negative 8. And these two would be my answers. Number 15, I've got x squared plus 4y squared equals 36. X squared plus y minus 3 equals 0. So you can do a few different things. I recommend elimination just because I have common exponents. So you can move this negative 3 first if you want to the right side so that it lines up with this 36, or you can just deal with it later. I'm going to deal with it later. The thing that you do have to be careful with though is in order to eliminate the x squareds, you're going to be subtracting. Okay, which means that every number in that second equation is being subtracted from the top one. So x squared minus x squared is what we are looking to do. So that one's easy. Then you got 4y squared in the top, and there's nothing being subtracted from it on the bottom. There's no 4y squared, or there's no y squared term on the bottom. So 4y squared is going to stay normal. Then when I look at my y terms, there's no y term in the top. So technically there's like a 0y, if you will. But then it's going to be minus y, which is just going to leave us with literally minus y. And then on the left side of the equation, I don't have any integer or any constants. So again, there's technically like a 0. So when I do 0 minus negative 3, it's going to change to plus 3. And then on the right hand side, I've got 36 minus 0, which doesn't change 36 at all. And then again, I've got a quadratic that I need to go ahead and solve. So I'm going to subtract 36 from both sides. And then I'm going to get 4y squared minus y minus 33 equals 0. Now, if you try to factor this, you can't factor out your 4. I didn't try bottoms up. You could, but I'm already kind of just nervous looking at 4 times negative 33 is going to be really, really big, and it has to add to be -1. So it's at this point, especially for time's sake, I would probably just go ahead and do the quadratic formula. So our quadratic formula is going to be negative b plus or minus square root of 4, b squared minus 4ac all over 2a. So negative b will be negative, b is -1, plus or minus the square root of b squared, so it'll be -1 squared, minus 4ac, so it'll be minus 4 times a is 4 times c is -33, all over 2a, so it'll be all over 2 times 4. And then we just need to simplify this. Negative -1 will be +1, plus or minus the square root of 1. A -4 times 4 times -33 will change to a positive, and that'll be 528, all divided by 8. Well, the square root of this ends up being 1 plus 528 is the square root of 529, which is 23, which is a great number. So then I end up with 1 plus or minus 23 over 8. So then this happens, I have a couple options. I have 1 plus 23 over 8 and 1 minus 23 over 8. So 1 plus 23 is 24. 24 divided by 8 is 3. 1 minus 23 over 8, or sorry, yeah, is going to be -22 over 8, which you could keep as a fraction, but if you notice the decimal is, it's a rational number, it stops. You can leave it as -2.75, however you want to deal with it. The thing you have to remember though is, and what's usually weird is you use quadratic formulas to find x's. We actually just found, since we eliminated the x variable up at the top, we're dealing with the y's. So we actually just found y is equal to 3 and y is equal to -2.75. So when you substitute these values back into one of your original equations, you need to be substituting them back into as y instead of as the x. So I'm going to plug mine into the second equation, just because I think it's a little bit easier. I don't know. So say, okay, if y is equal to 3, then that implies the bottom equation says x squared plus y is 3 minus 3 equals 0. Well, 3 minus 3 is 0, so then the only way for x squared to equal 0 is if x is equal to 0, which implies the ordered pair 0, 3. When you plug in 0 for x, the y value is 3. So there's one of our answers. And then we have -2.75 to plug in. So when y is equal to -2.75, I'm going to get x squared plus -2.75 minus 3 is equal to 0. So then I get x squared, -2.75 minus 3 is -5.75 equals 0. So I'll add that to both sides. I get x squared equals 5.75. And then I'm going to take the square root of both sides. And I should have written this in the directions, and I apologize. First of all, when you take the square root, it's going to be plus or minus. I'm okay with you rounding to the nearest tenth on this one. I guess we could have done hundredth. Either way, or it might actually be a normal number. I don't have my calculator to check. Again, I just have my original work that I did when I worked this out the first time. Okay, either way, there are two different x values. Okay, we've got the plus and minus version, both yield a y value of -2.75. So when you actually take the square root of this, you're going to get plus or minus about 2.4. So we end up with a positive 2.4x will yield a -2.75y. And a -2.4 will also yield the same -2.5. So there are 3 answers to that system of equations. Okay, number 16, x squared plus y squared equals 13. xy plus 6 is equal to 0. Again, this is another situation where you can't eliminate because you don't have any exponents that are the same. So again, I would take my bottom equation and solve it for one of my variables, and we'll substitute. So I'm going to solve mine for y. If I subtract 6 from both sides, then I get xy equals 6. So then I get y. Let me solve for y. Y is equal to -6 over x. Then I'm going to substitute that value for y back into my original equation. So when I do that to the top equation, I get x squared plus negative 6 over x squared is equal to 13. Okay, then I get x squared plus negative 6 over x squared is going to end up being 36 over x squared equals 13. So this is that new concept that we discussed in class where, from here there's nothing you could do. You can't factor this. Isolating x squared is doggone near impossible. So what we're going to do is something called u substitution. Okay, well, let me move that 13 first. If I move that 13, I get x squared plus 36 over x squared is equal, minus 13 is equal to 0. Okay, so if I do something called u substitution, it's basically saying, okay, let me define, let's suppose that u is equal to x squared. Okay, well, actually, before I do that, I'm ahead of myself here. I need to get rid of my fraction first, right? So if I want to get rid of my fraction, I want to multiply everything by x squared. So when that happens, I end up with, when I distribute this x squared to every term, x squared times x squared is x to the 4th, plus it cancels out in this fraction to just give us 36, minus 13x squared equals 0. And then again, this is kind of like a quadratic, right? If I rearrange it, I get x to the 4th minus 13x squared plus 36 equals 0. It's kind of like a quadratic, but not quite. My exponents are 2 more than what they should be. So this is going to be where we're going to use u substitution. We're going to suppose u is equal to x squared. So if u is equal to x squared and I have x to the 4th power, then in order for the right side to be x to the 4th power, this would be u squared minus 13 times x squared, literally it's just u, plus 36 is equal to 0. Now this looks lovely. This looks just like a quadratic that we can solve using the sum and product we can factor. So what two numbers multiply to be 36 add to be negative 13 will be u minus 9 times u minus 4 equals 0. And then you actually solve it for u. Say, okay, what values of u make this true? Well, u could equal 9 and u could equal 4, and it would make this true. Now, we solved for u, but the whole point was to actually solve for x, right? So now we're going to resubstitute this u substitution where we said u is equal to x squared, and instead of u equals 9 and u equals 4, we're going to say, well, x squared is equal to 9 and x squared is equal to 4. And then you're going to figure out what these are. Well, if I take the square root of both sides, I get x is plus and minus 3 and x is plus and minus 2. So I have 4 different x values for this intersection. Positive 3, negative 3, positive 2, negative 2. So again, you can substitute them back into either one of the original equations. The bottom one looks a little bit easier. In fact, you could do y equals negative 6 over x and substitute these 4 values in for x. So let me just do 3 first. If I substitute 3 into this, negative 6 divided by 3 is negative 2. So 3's pair will be negative 2. If I substitute negative 3 into this, negative 6 divided by negative 3 will end up being a positive 2. And then we're going to substitute 2 and negative 2. So if I substitute a positive 2, negative 6 divided by positive 2 is a negative 3. And when I substitute in a negative 2, negative 6 divided by negative 2 is a positive 3. So negative 2, 3. So there are 4 answers to that system of equations.